Hey guys, welcome back. So today we're going to be solving two-step equations. Now this is different than one-step equation. This obviously because this one is going to require us to do two different inverse operations as opposed to one. Now anytime that we are solving equations, we're going to be looking to do our order of operations backwards. So as we think about our order of operations, most people remember them as PEMDAS. So generally, we're going to be working them backwards. So in most forms, we're going to be doing the inverse of adding and subtracting first. And then the inverse of multiplying and dividing second. So let's look at our first problem. 9a minus 2 equals negative 65. So the first thing I'm going to do is separate my equation at the equal sign. Whatever I do on one side of my equation, I have to do on the other. So we want to do our adding and subtracting first. So I'm trying to get this a by itself. So to get the a by itself, I need to get rid of the minus 2. Well, the opposite or the inverse operation of subtraction is addition. So I'm going to add 2. If I add 2 on one side, I have to add 2 on the other side. Negative 2 and positive 2 make a 0 pair, so those cancel out. So I get 9a equals negative 63. Nine a equals negative 63. This is 9 times a. So we're going to do our multiplying and dividing second. This problem says 9 times a equals negative 63. So the opposite of multiplying by 9 is to divide each side by 9. So that the 9s cancel out. So we get that a equals negative 7. Now we could always check our answer by plugging our answer back in for a. So 9 times negative 7 minus 2. And we're going to see, does this equal 65? Well, 9 times 7 is negative 63. Minus 2 is negative 65. So it does. All right, so let's look at number 2. Negative 4x plus 7 equals 31. I'm going to draw a line down my equal sign. Whatever I do on one side, I have to do on the other. So remember, I'm trying to isolate the x or get rid of the x by itself. So first thing I'm going to do is get rid of the plus 7. So the opposite of adding 7 would be to subtract 7. So I'm going to subtract 7 from each side. So the positive 7 and negative 7 cancel out. So I get negative 4x on the left. 31 minus 7 is 24. To get rid of the times negative 4, I would divide each side by negative 4. So the negative 4's cancel out. So on the left side, I've isolated the x. 24 divided by negative 4 is negative 6. So my answer is x equals -6. We could check our answer by plugging it back into our problem. So -4 times -6 plus 7. We're going to see, does this equal 31? -4 times -6 is positive 24. Plus 7. 24 plus 7 is 31. All right, number 3. I'm going to draw a line down my equal sign. Now I'm trying to solve for k here. So whatever I do on one side of my equal sign, I have to do on the other. So first thing I need to do is get rid of this -11. So the opposite of subtracting 11 would be to add 11 to each side. So -11 and positive 11 cancel out. So I have k divided by 3 equals -5 plus 11 is 6. Now on the left side I have k divided by 3. The opposite of dividing by 3 is to multiply each side by 3. So I multiply the left side by 3 and the right side by 3. So the 3's cancel out. So I'd just be left with k equals 18. I'm going to write that a little bit nicer down here. Now we could check our answer by plugging it into our original problem. So I get 18 divided by 3 minus 11. And we're going to check, does this equal -5? 18 divided by 3 is 6. So I get 6 minus 11, which is -5. So this works. All right, so what I'd like you to do is pause the video and try this problem. Pause the video, try this problem. All right, so hopefully you paused the video and you tried this problem. So here's our equal sign. So the first thing we want to do is do our adding and subtracting. We're trying to get away items from the W on the right-hand side. So this W has this times -5 and this positive 23 over here. So what we want to do, since the 23 is positive, is we are going to subtract 23 from each side. Because the 23 is positive. So this will give us -15 equals -5W. Because the -23's cancel out. And then I'm going to divide each side by -5 to get the -5 away from the W. So we get positive 3 equals W, which is the same thing as saying W equals 3. And then again, we can check our answer. We're saying, does 8 equal 23 minus 5 times 3? Well, 5 times 3 is 15, so 23 minus 15 gives me 8. All right, number 5, 0.4x plus 9 equals 11. So I'm going to draw my line on my equal sign. So the first thing I'm going to do is subtract 9 from each side. So the 9's cancel out. Then I've got 0.4x equals 2. And then I'm going to divide each side by 0.4. So that the 0.4's cancel out. So on the left side, I just have x. Now we ask, how do we divide 2 by 0.5? Or excuse me, by 0.4. So if I have 2 divided by 0.4, and I want to move the decimal point 1 to the right so it's not a decimal anymore, then I have to move the decimal point on the numerator 1 to the right. So this is the same thing as 20 divided by 4, which is 5. So x equals 5. And again, we could always plug in our answer by checking it, or check our answer by plugging it in. So 0.4 times 5 plus 9. We're going to see, does this equal 11? Well, 0.4 times 5. 4 times 5 is 20. And I've got 1 decimal point here, so I've got 1 decimal point. So this equals 2. So 2 plus 9 is 11. All right, and our last problem today, x minus 1 divided by 6. Now, for all of our problems, we've always been doing our adding and subtracting first, because this is when we're doing our PEMDAS. And we do it backwards. Adding and subtracting comes first. Now here we have this x minus 1 all divided by 6. This x minus 1 is like it's in its own parenthesis. So when I do my order of operations here, my parenthesis part is going to be the last one that I do. So the first step for this one is to get rid of the divided by 6. So here I'm going to multiply each side by 6 to cancel out the divided by 6. So I have x minus 1 equals 12. And then I would add 1 to each side. So I get x equals 13. So to check our answer, we plug in 13. So 13 minus 1 divided by 6. Does this equal 2? Well, 13 minus 1 is 12. So this is 12 divided by 6, which is 2. So this one works.